Hi, and welcome to this video. Today we're going to take a look at some of the basic statistical concepts. Those include histogram, normal distribution, mean, median, mode, skewness, and box plots, as well as outliers. So we're going to start off with a histogram. So right here, you're given a data about 50 students in your math classroom. All of you decide to take a math test that is scored out of 50. So on the x-axis, we have a score that is out of 50, and then on the y-axis, we have a number of students that got that score. So on the data here, it's said to you that you have 2 students that score between 0 and 10. So you plot it like this. Imagine there's a 2 here, and then we get 2 students. We do the same thing with 5. We go until 5, like that. 15 between 20 and 30. So we go all the way up to 15. 30, good, and then 17, that's slightly higher, and then 11, somewhere like here. So this is what we typically call a histogram. So histogram, it basically shows you how many people or how many observations were between certain values. So right here I have 2 between 0 and 10, 5 between 10 and 20, 15 between 20 and 30, and so on and so forth. So histogram really allows you to see the shape of the distribution. In this case, we can kind of see that the distribution looks like this if we were to even it out. So to help us even it out, we're going to increase our sample size. And let's say we increase it to 200 students. And with all of that, our distribution will start looking like this. With more and more students that we add, our distribution will become clearer and clearer. And right here, imagine we have 10,000 students who took the exact same test out of 50. So our distribution looks almost like this. And as you can see, the more you increase the sample size, the better the histogram allows you to see the data and to see the way it's distributed. So with all this in mind, I'm going to move on to normal distributions. As you can see from the histogram, we've got the distribution, and it kind of resembles a normal distribution. Normal distribution is the most common types of distributions, and it's really the best one to work with because it allows us to calculate the probabilities, the chance of something occurring, and so on. So, normal distribution is usually the one that we call a bell shape. So right here, this is our normal distribution, and I'm going to put it on the side, but you might notice how it slightly resembles a bell. This is why we call it a bell distribution. So bell distribution or normal distribution, examples of it could include weight, height, scores, or food in a local restaurant on a given day. So for example, for the height, right here you have people who are 6 feet. In the middle, or for average, you have, for example, 5.3. And then here, maybe 4, somewhere like this. So the further away you move from the distribution, the smaller the value gets. So right here, you might have someone who's 3 feet tall, so which is pretty rare. So normal distribution, you can be used for almost anything really. As long as you have a pretty big sample size, it usually comes out being normally distributed. According to our previous example, the scores can also be used for normal distribution, as well as food sold in a local restaurant on a given day, which is our fourth option. So let me illustrate how that's going to happen. So imagine you have this distribution and the number line. So, for example, let's say that this local restaurant sells about 100 plates every day, on average. But for example, let's say they decided to be open on Christmas. And they had a lot of people coming in. So right here we have our data that is collected on Christmas. And they sold 400 plates. So this is a pretty rare occasion. So the probability of this happening will be very small because, Christmas is not every day. But then, for example, majority of the time they would sell somewhere between 60 and 140. So that's kind of how we can use normal distribution to show how rare something is or how common something is. the closer the data point is located to this average, the more expected it is to happen. There's higher chance of it happening, and it's a more usual occurrence. Now let's move on to the tools that we use to describe normal distribution, and those include mean, median, and mode. So let me start with the mean. Mean is actually the same thing as average. It's just a fancy word that we use in statistics. Mean is the average, so the formula for it would be x1 plus x2 plus x3 plus continue until xn, and then divided by n. So I'm pretty sure a lot of you know how to calculate the mean. So that would be, for example, here we have 1 plus 3 plus 4 plus 6 plus 9. And how many there? So 1, 2, 3, 4, 5. We divide it by 5. That's 23 divided by 5. And that will give us 4.6. Okay, so we got our mean, and then we're going to move on to the median. Median is literally just 50% of the data. So it is the point that divides the data. We have 50% here. Then we have our value, let's say x, and then 50% here. So it literally is just the middle value. So right here, we have an example of 1, 2, 4, 6, and 11. So what is the middle value? Here we have 1, 2, so that's 2 together. 1, 2, those are also together. And then here we have 4, but that's our median value. So median is equal to 4. In the next example, we have an even number, so we have 6 instead of 5, like here. So what do you do in this case? We can calculate that here we have 1, 2, those two are together. 1, 2, those two are also together. And we have two values in the middle. So what do? We just calculate the number in between them. So we have 112 plus 114 divided by 2. That gives us 113. So the median is equal to 113. Great job. Okay, now we're going to go to mode. Mode is just the most common value. The most common value. So, let me illustrate it by example. So here we have our example of the mode. So let's count how many ones we have. We have 1, 1, we have 1, 2, we have 2 3s, we have 3 4s, 1 5, 2 6s. So, what is the most common value here? We obviously have 3 4s, so this is the most common number. So we have mode is equal to 4, because it's the most common value here. Next one, we have 3 1s, 2 2s, 3 3s, then 1 4, 1 6, and 1 7. So we have two more common values because we have 3 1s here and 3 3s. So what do we do in this case? We just put two modes. We say mode is equal to 1 and it's equal to 3. It's okay to put two modes, but if you have to put more than 3 modes, the mode by itself becomes a pretty poor indicator because there's just way too many common values. So with that in mind, we're going to move on to the skewness. So right here, I'm just going to quickly explain what skewness is when you have this kind of distribution, and you can clearly see that this tail is pretty short and this tail is pretty long. So when you have a long tail, that showcases there's slightly unusual values because majority of the values is located here. But then suddenly you have like a value of 0 or 1 that just pulls everything to the side. So this showcases the skewness because there's just unusually low values right here, and all the distribution just moves to this side to catch those values. So we say that the distribution is skewed to the left when I see this. Next one is skewed to the right. So as I've mentioned here, so we have this tail that is pretty short and this tail that is pretty long. So because the right tail is long, we say that it's skewed to the right. because there's probably some really high numbers, let's say 1000, that pulls this tail to the side like this. Next one, we have the not skewed distribution. One tail is pretty much the same thing as the other tail, plus if you separate this distribution in two, it's kind of like a mirror image of each other. One side is just like the other, so we just say that this is a not skewed distribution. There's an important note here that with skewed distribution, median is a better indicator of the middle data than the mean, because the mean is greatly affected by extreme values, which are outliers. So let me show you what I mean. Right here, we have a distribution that is skewed to the left. So as I already mentioned, if it's skewed to the left, it probably has very unusual small values. And as we can see here, it has 0 and 1 as a very small numbers. Majority of the data, though, is located in the 90s. So this is highly unusual. So let's try to calculate the median and the mean for this data. First, let's take a look at the median. Let's calculate how many values there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 values. So there should be 5 from each side. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 93 is in the middle. It's our median. You can stop the video to calculate the mean if you want, but I'm just going to show you the values. So the median is 93, whereas our mean is 77. As you can see, majority of the data is located in the 90s. And the median actually reflects it quite well because it shows that the median is 93. However, with the mean, it shows 77 because this is greatly affected by the small values that we have, 0 and 1. So if you're looking at a distribution that is highly skewed, it's really important to look at the median instead of the mean because the median is actually a better indicator of where the majority of the values are located. Now let's move on to the box plots. So box plots may look slightly unusual in the beginning, but I promise they're okay. So first one, first thing that we notice, the box plot is divided into quartiles. Those are those little cues. So quartile 1 is 25% of the data. Quartile 2 is 50% of the data, which is the same thing as a median. So this line right here showcases us the median. And then quartile 3, as you might have guessed, is 75%. So in this box, we have 50% of our data, and everything else is located in those areas. Now let's take a look at some of the box plots. So when we have a skewed left distribution, it might look like this on a box plot. So what is this little thing, you might ask? So this little thing is our outlier because we have a data that is highly skewed. So right here, we might have very small values that are really far away from the average. And to showcase this on our box plot, we put this asterisk that means outlier. So this is literally outlier. And as you may have noticed, this median is slightly not in the middle. If it was in the middle, it would be right here, but then it's slightly to the side. So if it goes closer to the right side, this means that the distribution is skewed left. This happens because the mean pushes the distribution to the side, whereas the median stays where majority of the data is located, which is slightly to the right of the distribution. Now we're going to move on to the skewed right distribution. And we have just the polar opposite of what we just had here. So we have the outlier on the right. This is again called outlier. This is outlier on the upper side. So this means that there's a high value like 1000, for example. And as you may have noticed again, we have a median that is slightly to the left. So it goes right here because the outlier pushes all the distribution to the right. So the median stays to the left where majority of the data is. And lastly, we have the not skewed distribution. This one, the tails are similar. The median is located in the middle, so this showcases that the distribution is not skewed and is kind of symmetrical. Thank you so much for watching this video. In the next one, we're gonna calculate percentages and quartile values, as well as identify outliers and their values in box plots. Thank you. Bye-bye.